small scale, there may be certain area that precision and recall increase, both increase. Okay, so so this is one of the motivations for the mean average precision matrix. Okay. So suppose the classifier has 90% precision and 10% recall. Okay, but 96 precision and 20% recall. Okay, assume it is like that. Okay, of course this I'm not describing that figure. Okay, that figure is different from this one. Okay, but let's assume we have such a situation. So there's really no trade-off. Okay, because obviously, like both precision and recall increase, precision increase from 90% to 96%, and the recall increase from 10% to 20%, right? So it makes more sense to use the classifier at 20% recall rather than at a 10% recall, right? Because you will get both higher recall and higher precision, right? Okay. So instead of looking at the precision and the 10% recall, we should really be looking at the maximum precision that the classifier can offer with at least 10% recall. Right? Okay, at least 10% recall. How much your model, what is the maximum precision your model can offer? Okay? So it would be 96%, not 90%. Okay? So therefore, one way to get a fair idea of the model performance is to compute the maximum precision you get with at least 0% recall. Okay? And then 10% recall, 20% recall, okay? At least 0% recall, at least 10% recall, at least 20% recall, and so on, up to 100% recall. Okay. So you have a bunch of maximum precision, okay, that you can obtain from like different considerations. Okay, so totally you have actually 11 different maximum precision. Okay, for 11 different considerations. Okay, so you can calculate the mean of this maximum precision. Okay, this is called average precision. Okay, matrix. Okay, so now we have average precision. Okay, we still need that mean average precision. There's still one mean that we haven't considered, right? Okay, now when there are more than two classes, because you can do this for one class at a time. So say you are classifying 3 classes, then you will have this average precision for each class, and then you can again get the mean of this average precision. Okay, and that will be your mean average precision. Get idea? Okay. For each class, you try to find out the maximum precision for different considerations with at least 0% recall, with at least 10% recall, with at least 20% recall, and so on, up to 100% recall. So you have 11 different considerations, and you get 11 different maximum precisions, and you do the average to get the average precision for that particular class. And if you have multiple classes, then for each class, you compute that average precision, and then you do an average. Then it will be your mean average precision. Okay. Up to now, okay. Hopefully, by now, okay, up to this point, you understand what I'm talking about. Okay. But okay, it's not done yet. We are going to continue on this track. Okay. In an object detection system, okay, there's an additional level of complexity, okay, because the system not only detects the class, but also it has to detect the location, right? The bounding box, right? The bounding box. So if the object is detected, is classified correctly, but the bounding box is completely off, we probably shouldn't say that's a correct object detection, right? Okay. So, okay. So in that case, we should not count this as a positive prediction. Okay. So one approach is to define IOU threshold. Okay. IOU, we already talked about what IOU is, right? It's a value between 0 and 1, right? Between 0 and 100, right? So and we can define an IOU threshold, okay? For example, we may consider that a prediction is correct only if IOU is greater than, for example, 0.5. And the prediction class is correct. So these two things have to happen, at the same time. Okay, IOU exceed that threshold and the prediction class is correct. So the corresponding MAP is generally noted as MAP at 0.5, okay, or MAP at 50%, okay, or AP50, okay, AP50, okay. So in some conditions, okay, such as Pascal VOC charge, okay, of course we can imagine Pascal VOC charge use Pascal VOC data set, right? We talk about Pascal VOC data set, which is used to train the YOLO, right? So this is what it is done. Okay, so they are looking at MAP at 50% to determine which model is the winner. Okay. So this is what is done. But in other competition, such as COCO competition, COCO is another data set. Okay.